class. So while we are out of school and trying to do school from home, I would like for us to have the opportunity to go over the questions that I assigned out of your textbook and to go over the procedures for solving those. So this video is showing how to work out the problems that I assigned from lesson 89. And our first one was number 1. So in number 1, it's talking about Andy is designing a large doghouse. 1 inch on the drawing equals 4 feet on the real doghouse. So A says if he draws the doghouse 3.25 inches long, how long is the actual doghouse? So I created a ratio table here. If 1 inch is equal to 4 feet, and the drawing is 3.25 inches, that lets me create a proportion. 1 inch is to 4 feet, as 3.25 is to what? I can do my cross multiplication, and the real doghouse would be 13 feet. Okay? B says, if the doghouse is to be 6 feet wide, how wide must the drawing be? Okay, so I just reversed it. I have my scale is 1 inch is to 4 feet. So in this time they give me the actual width of the doghouse. So I create my proportion, 1 is to 4, as what is to 6. And then I solve and I get my drawing should be 1.5 inches wide. Okay? Number 3. This was several steps involved in this problem. If the value of a $100 stock drops 10% in 1 year and then increases 10% the next year, what's the value after the increase? So I did the first step. I did the drop of 10% in 1 year. If I start out with $100, I have my original change new. My new percent is 90. So I compared 100% is to 90% as $100 is to my new value. I do my cross multiplying. So the value of the stock after a 10% drop would be $90. Okay? So now this is my new amount of money. So now I'm going to show what would happen with my starting out with $90 and then increasing the value of my stock 10%. So my new percent here is 110%. So now my proportion is 100% is to 110% as $90 is to what? I do my cross multiplication. So the value of my stock now is $99. Okay, number 4 is a multiplying in scientific notation. So 3.6 times 10 to the 3rd seconds times 8.76 times 10 to the 3rd hours. And I get 31.536 times 10 to the 6th. But 31.536 is not proper scientific notation. So this turns into 3.1536 times 10 to the 1st. And then I bring my times 10 to the 6th down in. So my final answer is 3.1536 times 10 to the 7th seconds. Okay? The next one is number 6. This is a conversion problem. So we start out with 1 cubic meter, and they want us to go to cubic centimeters. Okay? So meters cubed, that means I have to have 3 unit multipliers. 100 centimeters is to 1 meter. So meters times meters times meters gets rid of my meters cubed. 100 times 100 times 100 is 1 million centimeter times centimeter times centimeter, centimeter cubed. Number 7, they want us to add these trinomials. Okay, the first trinomial was x plus 2y minus 4. The second trinomial was negative x, negative y, plus 2. So if I have an x and a negative x, positive x, minus x, I don't have any more x's. Positive 2y, negative 1y, positive 2, negative 1 gives me as a result of positive 1. Y. Negative 4, positive 2 gives me a result of negative 2. So now I have 1 positive y and a negative 2, y minus 2. This is numbers 8 and 9. This has to do with our building that they had drawn for us. The first question, number 8, wants to know the volume of the building, okay? The volume of the building. Now, our formula for volume, okay, equals capital B. Remember, our capital B is for area of the base times the height. But in this figure, it's not just a complete rectangular prism, okay? We've got a rectangular prism part with a triangular prism on top of it. Okay, so I've got to find the volumes of those two different areas. So over here, I have found the volume of my rectangular part, the bottom part of the building. Okay, so for my capital B area of the base of my building is 20 by 20, so 20 times 20. My height is 10. 20 times 20 times 10 gives me 4,000 cubic feet for the rectangular prism part. Okay, now for my triangular roof part, okay, volume equals area of the base times the height. In this case, the base of my figure is a triangle all the way through. Okay, so I got to think about area of a triangle is base times height divided by 2. Here's the base of my triangle. The height is 4. My base is 20. 20 times 4 divided by 2 gives me 40 square feet. So my capital B is 40 square feet. Now to find my volume, I multiply my 40 times the height. In this case, the height is how far this triangle goes all the way back, okay, along the length of this building. So the triangular prism goes 20 feet back, so my height is 20. So together, 40 times 20 gives me 800 feet cubed. So the triangular part is 800, the rectangular part is 4,000. Together, the volume of the whole thing is 4,800 cubic feet. Okay? Now number 9, it says they want to paint the outside of the building. Okay, they're not going to paint the roof, just the 4 outside walls. Okay? So if I want to find the surface area there, I can find the perimeter of the base and multiply it times the height. Okay? So my base, my figure is 20 by 20 by 20 by 20. Okay? So that gives me 80 in perimeter. Okay? Times my height of 10 gives me 800 feet squared as my surface area that needs to get painted. Okay, number 11. It says on a sunny day, Jason notices that the flagpole has a shadow that's 4 times as long as his own shadow, and his height is 5.5 feet. So how tall is the flagpole? Well, if his shadow is 4 times, or the flagpole shadow is 4 times longer than his shadow, then the flagpole must be 4 times taller than the kid is. So his height is 5.5 feet, multiply times 4, so the flagpole must be 22 feet. Okay? Our next one is number 12. This is one of our radical problems. 2 times radical 6 times radical 15. So I went ahead and put all under the same radical, and then I broke my 6 and my 15 down into factors. Okay? So I ended up with 2 radical 2 times 3 times 3 times 5. And I noticed that I have 3 times 3, which means I can bring the root out. 3 times 3 is 9. The root of that is 3. So now I have 2 times 3 on the outside. And then inside of my radical, I have 2 times 5. So my final answer is 6 radical 10. Okay, number 13 is radical 720. Okay, well, I kept breaking my 720 down. Okay, I first broke it down into 72 times 10. And then I broke my 72 into 8 times 9. And my 10 into 2 times 5. And then I said, well, I know 9 is a perfect square, so I can bring the root out, which is a 3. So I said, okay, I'm going to bring my 3 out, 3. And then I took my 8 and I broke it down into 2 times 4 times 2 times 5. And then I thought, well, 4 is a perfect square, so I can bring a 2 out. And then I have 2 2's, which is another 4, so I can bring another 2 out. So that gave me 3 times 2 times 2 on the outside, and radical 5 on the inside, which is a final answer of 3 times 2 times 2 is 12, and then I have radical 5. Okay, number 14 is a problem where we have to know our rules for signed numbers, multiplying them, and combining signed numbers and order of operations. Okay? Negative 12 plus negative 3 times negative 4 minus a negative 5. Okay, so the first thing I did was multiplication. I multiplied negative 3 and negative 4, and I got positive 12. Okay, so this is already addition here, so that's fine. I have subtraction here. Instead of subtracting, I'm going to add the opposite. The opposite of negative 5 is positive 5. Okay, so now I need to add from left to right. Okay, negative 12 plus a positive 12 results in a 0. Plus positive 5 gives me an answer of 5. Okay, number 18 was a graphing problem. They wanted you to graph these two lines, y equals negative x and y equals x. Okay, so my first one, y equals negative x. If there's no plus or minus anything, my intercept is at 0. Okay, now this is a negative x, so that means negative 1 over 1 is my slope. So I'm going to start here. Here's my 1 point. If I'm going to have a negative slope of 1, I'm going to sink 1 and run 1. Okay, so this is the line of y equals negative x. Okay, my second line was y equals x. My intercept is at 0. My slope is positive 1. So I'm going to rise 1 and run 1. So this line represents y equals x. Okay, so it says what is the relationship between these two lines? These two lines are perpendicular. Okay, they're perpendicular. And then it says where do they intersect? They intersect at the origin. They intersect at 0, 0. Okay, number 19 is a system of equations graphing problem like we had yesterday. Okay, so our first equation is x plus y equals 1, and then we have x minus y equals 5. Now these are both in standard form, okay, so we would graph them using our intercepts. So my first one, x plus y equals 1, if x is 0, y is 1, and if y is 0, x is 1. Okay, so I went over here, 0, 1, 0, 1 is here, 1, 0 is here. This is the graph of x plus y equals 1. Okay? Now this one was a little harder because I had a negative y. So we've got to be very careful. Okay? So in this case, if x is 0, then I have to say negative y equals 5. Okay? So that means I need to divide both sides by negative 1 to get y equals negative 5. Okay? So if x is 0, y is negative 5. If y is 0, x is 5. Okay? So now I can graph here. 0, negative 5, 0, negative 5, and 5, 0. So this line represents the graph of x minus y equals 5. Okay? So like we did yesterday, we're going to see where they intersect. The point where they intersect is the value for x and the value for y. That is true for both of these. These lines intersect at 3, negative 2. So if x is 3 and y is negative 2, both of these equations are true. If x is 3, 3 minus 2, does that equal 1? Yes. Okay, if x is 3 and y is negative 2, then I would end up with 3 minus a negative 2. Minus a minus means add the opposite. 3 plus 2 does equal 5, so it works out in this equation too. So the solution to this system is 3, negative 2. Okay, number 23, we start out with x minus 4 equals 3x plus 2. Okay, so I need to combine like terms before I try to solve for x. So I'm going to move this x, I want it to be with this x. So I'm going to subtract x from both sides. So I end up with x minus x is no more x's on this side. 3x minus x is 2x. So now I just rewrite. Negative 4 equals 2x plus 2. Okay? Now I want my numbers together. So I'm going to take this positive 2, and I want to move it over here with this negative 4. So if I'm adding 2 here, I need to subtract 2 to move it. Subtract 2, subtract 2. Okay, so I end up with negative 6 equals 2x. Now I want x by itself. What's happening to x? X is being multiplied by 2, so I get it by itself by dividing by 2 on both sides. Negative 6 divided by 2 is negative 3. Okay, last one. 5/9 x minus 1/3 equals 2/3. Okay, what's happening to the term with the x is being subtracted by 1/3. So how do I undo that? I'm going to add 1/3 to both sides. Okay, if I add 1/3 here, negative 1/3, positive 1/3, these are gone. 2/3 plus 1/3 gives me 3/3, which is the same thing as 1. So I have 5/9 x equals 1. Now we could solve this by multiplying both sides by the reciprocal of 5/9, but I saw when I got that this was equal to 1, I know that any fraction times its reciprocal is equal to 1, so I knew that x had to be 9/5. If you didn't see that, you could also say, well, to get x by itself, I have to divide by 5/9, which means multiply by the reciprocal. Okay, so this takes care of this. X is equal to 9/5. Okay? Okay, so check your work. Make sure you are holding on to these work assignments. Hopefully they are in your notebook. Hopefully you did okay. And that's it for this homework from lesson 89.